Hey there, my name is Alejandro, and welcome back for day 25 of me doing the NeetCode 150 challenge. So today we're doing another bit manipulation problem, and let's get straight into it. Okay, problem 191, number of 1 bit. Write a function that takes the binary representation of a positive integer and returns the number of set bits it has, also known as the Hamming weight. Okay, can we not just literally do something like bin of n dot count 1? Or return this, I should say. Can we not just do something like that? No way. Less than 1 minute submission? First time on this channel? Yo, no way. Beats 98%. Okay. Okay, I didn't expect it to be that easy. Right, I mean, I'm trying to think of like... This is not even bit manipulation. This is just direct bit query. I mean, I'm kind of stunned. Like, what else is the expected solution? It's just you count the number of 1 bits, right? It's just you go over the binary number as if there was a string, count the number of ones, and there you go, right? Okay. Okay, sorry, I'm starting myself. Okay, as always in all my videos, I do a quick recap of how I was able to solve the problem. This one I was able to solve quite quickly. The point is, if I take a number like 11, right? The point is, if I convert it into its binary representation, right? So if I do bin of 11, essentially this will give me the binary representation for 11, right? So let's think of 11, right? So I can either have 0, 1, 2, 4, or 8. So it's 8 plus 3, right? So it'll be, so 3 is 1, 1. This will be, so that's the 2s, this is the 4s, and this is the 8s, right? So this should be 11, right? So this is 1, this is 3. If I did this, this would give me 4, so this gives me 8, right? So just to confirm, you know what, let's whip out the terminal, right? So let's just do bin of 11. But yeah, it gives us a 1011, right? And so whenever you do bin in Python, the very first thing that it does is put 0b, right? But that doesn't matter, right? Because the number of ones and so on is essentially the numbers we want in here. Both of these random characters that get added at the very beginning are not ones anyway, so we just want to count the number of ones, right? But the point is that we convert into a number of ones like this, and then essentially we count the number of ones, right? So another way we could do it is, you know, we do like count is equal to 0 for binary digit in or for bit inside of, you know, bin of the number, right? I could do count plus or equal to 1, right? And then it's like return count. And so if I comment out that return statement and I just run this code, then essentially like oh, this does not work as well. Am I like off by 1? For bit in binary number of n, count plus or equal to 1 if bit is equal to 1, right? Else 0. Sorry, now I'm just counting the, like, you know, the length of the binary number is L plus 2. But like here, if I do that, essentially it's like, okay, that's essentially it, right? I'm just counting, so I transform the number into its binary representation, and then I just count the number of ones that happen in the number, right? So it's literally just this, except that in Python, you know, you can take a string, and there's a count method, right? That essentially counts how many occurrences of a substring exist in that string, right? It might be with just one character and so on, but at least with just one character, I know that works. So that's why I just did count and so on. But essentially it's just the equivalent code of this, right? It's just like for every single bit in the binary representation of the number, I essentially like increment my counter by 1 if that bit is a 1 value, right? Because I'm counting the number of times that this substring happens, i.e. this character with just the value 1 inside of it. Otherwise I increment count by 0 because it is not a set bit, right? And then at the very end I return that count. And it's just a funny Python short way of doing the very same thing. So yeah, I hope that explanation made sense. Okay, this is a very simple problem. But otherwise, that's pretty much it for this video. Let's just make sure that we check the box saying that we solved this problem, and that's pretty much it. So without further ado, I guess it's just I don't even know what to say. I'm like so stunned by how simple this problem was. But okay, nevertheless, that's pretty much it for this video. If you did find it useful or enjoyable in any way, shape, or form, I would highly appreciate if you left a like or a comment. But otherwise, I'll just catch you in the next one. So until then, ciao, ciao, my friend. Bye bye.